Hello, I'm Alberto Soto with Siemens PLM Software. Today, I'm going to show you how to link the battery cooling system of an electric vehicle with the air conditioning system. This link will allow you to increase cooling power in order to maintain the battery under the right operating conditions. To do this, let's use the electric vehicle battery cooling demo in SIEMcenter AMSIM. This demo shows how SIEMcenter AMSIM supports the model-based design process on an electric vehicle battery example. You can find this example under the Solutions demo section. Then, go to Automotive, Hybrid and Electric Vehicle Integration, Electric Vehicle, and then select Battery and Cabin Cooling Loops Coupling in a vehicle model. This demo is already composed of a vehicle and an electrical part, which have been designed during the previous steps of the model-based design process. Now, let's switch to the cooling system model of this demo. The battery thermal model is represented with two separate masses, one for the cells and another one for the casing. A water cooling heat exchanger is directly connected to the casing to cool it. The two cooling power sources in this exchanger are a radiator, which cools down the coolant with an ambient temperature airflow, and a chiller, connected to the air conditioning loop to get more cooling power. The cooling strategy is defined through a state chart, depending on battery and cabin temperatures. In a single run, the ambient temperature is set at 30 degrees Celsius, and priority is given to cooling the car cabin. You can benefit from the following post-processing: the evolution of the car cabin and battery temperatures and the associated threshold, the discomfort duration. Priority could also be given to cooling the battery, or finding a compromise between the two previous strategies. Let's see the impact of these different strategies, as well as various ambient temperatures. You can then see the impact on the battery and ambient temperatures depending on each strategy. If you would like to use cross results for a more dynamic post-processing of the discomfort duration, let's proceed as follows. First, display the cross results dialog. Then add the discomfort duration cross variable by selecting it from the list. You can now create the plot by drag and dropping the desired variable. To sum up, on this example, we have seen how SIEMcenter AMSIM can be used to model a battery cooling system that is fully integrated in a complete vehicle model. We have presented how to perform tests in thermal stress conditions and how to analyze results in order to validate the design. Finally, we have shown how the state chart feature may be used to implement different control strategies. Thank you for watching. For more information, please visit our website.